In lesson 4.8, we're going to look at applications of trigonometric functions, simple harmonic motion. And these formulas are in your book. We have an object that moves on a coordinate axis, is in simple harmonic motion if the distance from the origin, d, at time t is given either by the formula d equals a times the cosine of omega times t. Cosine is used if the object is at its greatest distance from rest position if t, the time, is 0. So when no time passes, if it's at its greatest distance from rest position, you use cosine. Or you would use sine, which is d equals a times the sine of omega times t, if the object is at rest when t is equal to 0. The motion has amplitude, absolute value of a. The period of the motion is 2 pi over omega, and this really isn't anything new because the period of the parent function, cosine or sine, would be 2 pi. And anytime we have a coefficient here, we would always divide by it to make the adjustment for the period. But omega has to be greater than 0. And likewise, frequency of an object in simple harmonic motion. An object in simple harmonic motion, using either this formula that we stated above or this formula, has a frequency f equals omega over 2 pi, where omega is greater than 0. So notice that the frequency is just the period reciprocal. So I just flip it. So equivalently, it can be written like this. So how do we use this in a real world problem? A ball on a spring is pulled 6 inches below its rest position. So that tells me I'm going to use cosine because I've got that maximum distance at rest position of 6. Then it's released. The period for the motion is 4 seconds. Write the equation for the ball's simple harmonic motion. So first of all, the amplitude is going to be here, 6, because it was pulled 6 inches. The word below its rest position tells me I'm going to use a negative coefficient. And then to find omega, I just need to take the formula for the period of the motion, the one that I gave you up here, 2 pi over omega. So use that formula, set it equal to the period that they gave you, which was 4. Then do a little bit of algebra and solve for omega. So in order to solve this equation for omega, I'm going to multiply both sides of the equation by omega. That cancels out. So I have 2 pi equals 4 times omega, divide by 4, and then 2 pi over 4 reduces to pi over 2. So omega, which is the coefficient of t, is pi over 2. And that's all you have to do is set up that equation. The next example, an object moves in simple harmonic motion described by this formula. So they're giving us the formula. T is measured in seconds and d is in centimeters. Find the maximum displacement and frequency. So the maximum displacement is the same as the amplitude. So it's 12. And then to get the frequency, remember it's the reciprocal of the period. So instead of doing 2 pi over omega, I'm doing omega divided by 2 pi. Okay, this is what I'm using right here. So omega was given to us in the formula. It's just the coefficient of t. And then I always divide by 2 pi because that's the period of a basic cosine function. So remember, when you divide fractions, you're actually going to multiply by the reciprocal of the second fraction, or the second number here. The pi is going to cancel the pi, and we're going to have 1/8 cycle per second.